subject is AC machines 2 and topic is single phase induction motors. Here on completion of this period you would be able to know types of single phase induction motors. Types of single phase induction motors. Here, so requirement for producing rotating magnetic field. So for producing rotating magnetic field, two things are essential. There must be two windings. There must be two windings. They must have space displacement and also phase displacement of 90 degrees. Space displacement and phase displacement is 90 degrees. They must have space and place phase and space displacement is 90 degrees. Once again, for producing rotating magnetic field, two things are essential. There must be two windings. They must have space displacement and phase displacement of 90 degrees. Here, two magnetic fields are 90 degrees. That resultant is in blue color. These two are 90 degrees is placed for every time. See here, these two black. So fields which gives the resultants in blue color. See here this. Now classification of single phase induction motors. Classification of single phase induction motors according to the methods of starting. So resistance split phase motors or split phase motor, resistance split phase motor or split phase motor, and other one is capacitor start motor and capacitor motor. Capacitor start, here they given capacitor run. So capacitor start, capacitor run motor, shaded pole motor. Here classification of single phase induction motors according to the methods of starting. The resistance split phase motor or split phase motor and capacitor start motor, capacitor run motor and capacitor start, capacitor run motor and shaded pole motor. Here split phase motor, the split phase motor stator carries two windings. So first one is a main winding, one is the main winding, another one is the auxiliary or starting winding for starting purpose. Stator carries two windings, one is the main winding, another one is the auxiliary or starting winding for starting purpose. These two windings are displaced in space by 90 degrees. These two windings are displaced in space by 90 degrees. The rotor is mostly squirrel cage type. The rotor is mostly squirrel cage type. So now here the split phase motors. These are the split phase motors. Here a run winding and here this is the run winding and this is the start winding and this is the starting switch and AC supply This is the squirrel cage rotor SC. Squirrel cage rotor. Here, this is one of the capacitor is connected. This is for starting. So, capacitor starting. Next one is here. These are the squirrel cage rotor. So, these are the bars. So, here these are the end rings. These are the end rings. So, these are the copper bar or aluminum bar. This is the squirrel cage rotor, and this is also a laminated iron armature. This is laminated iron armature. So, this one is laminated stator pole. This one is laminated stator pole. Here end discs. This is so it is a shaft, axle and shaft. This is drive shaft. Axle and this is axle and drive shaft. So now this is the squirrel cage rotor. This is what an actual shows. It is a figure. This is the actual figure how it is. Next one is see here resistant start split phase motor. Resistant start split phase motor. Resistant start split phase motor. This is and split phase motor having 4 terminals. So here see here these are the 4 terminals. These are the 4 terminals. And resistance split phase motor phasor diagram. Here the supply is VT. Here VT is a reference along with the x-axis, and this is the running current IR, and this is the starting current switch, and total current IT. Here starting and running current. Here the phasor diagram, it shows that it is between them. So supply voltage and the total current. See here this total current VT, that means supply current. Here along with the x-axis it is taken as a reference, and this is IX means it is a reactance current, higher means it is resistance current. So IR is in phase with VT and IX is lagging by 90 degrees behind that of the VT. Now here the starting in the starting winding current is I start, that is denoted by the, so this is a red mark, starting current, and the running current, and this is the running current is denoted by the by color, so green color. This is the running current, here it represents that, and this combination, the starting and running, which gives the IT, that means the starting and the starting running, which gives the total. That means here by parallelogram method, run and start, which gives the resultant. This is the total current. Here this total current is lagging by 5 degrees behind that of voltage V, supplied voltage V. The supplied voltage V. And for getting phase displacement, here for resistance split phase motor, for getting phase displacement, the starting winding is designed as highly resistive. So for getting phase displacement, starting winding is designed as highly resistive. The main winding is reactive. The main winding is reactive. So now the main winding is current is iron. The running current lags V by nearly 90 degrees. Now starting winding current is I start. Starting current I start. Running working current is iron. Running working current is iron. The starting current I is almost in phase with, so the supply voltage, that is Vt, and in split phase running current and starting current produces two fluxes. They should have a phase difference of nearly 90 degrees for ideal split phase motors, but an angle is between 20 to 30 degrees. The condition of space and phase displacement are achieved, so rotating magnetic field is produced. So running and starting produces of two fluxes, they should have a phase difference nearly 90 degrees for ideal split phase motor, but the angle is between 20 to 30 degrees. The condition of space and phase displacement are achieved, so rotating magnetic field is produced. So motor develops torque. So motor develops torque. So motor develops torque. So here the split phase motor rotating magnetic field is showing. Here, see, observe this one, how it is rotating. So the auxiliary, the working principle of split phase motor, the auxiliary winding is not designed for continuous operation. So single phase supply given to the motor. When the motor picks up speed, the auxiliary winding is automatically disconnected by the centrifugal switch to prevent the motor drawing excessive currents. To protect the motor winding from overheating, it can be to protect the motor winding from the overheating. Next, reversal of rotation. It can be obtained by reversing either the main winding or auxiliary winding. It can be obtained by reversing either the main winding or auxiliary winding. Advantages: operate at nearly constant speed, reversible at low speed, so rapid acceleration and low cost. Once again, operate at nearly constant speed, reversible at low speed, and rapid acceleration, low cost. So disadvantages are repeated start or stop cycles hit the winding high due to high starting resistance. So less useful for large inertial loads. So split phase motor applications, fans, blowers, washing machines, oil burners, Electric tools. Once again, fans, blowers, washing machines, oil burners, electric tools, etc. Here, this is a split phase motor figure. Summary: we have discussed about the types of single phase induction motor. Thank you.